Alrighty, this is trigonometry for you people. Graph of sine and cosine functions. It's easy. Now, y'all have your unit circles out, so it's going to make it even easier. A periodic function is a function that's kind of like a wave. Okay, it's a wave, a sine wave, a cosine wave, but like your heartbeat, it is a periodic function. It keeps repeating. So it does the pattern and then it repeats. Does the pattern and then repeats. So it's a periodic function, and so therefore it just keeps going on. But then there is a start and an end of the pattern. And so that start and end of the pattern would be called the period. So how long it takes for it to make one whole cycle would be one period. So period function is such that, anyway. It is this, but I'll explain more because I hate the way that they write this out. Okay, repeats 2 pi. All right, so, no. Okay, so now, magic finger. Time for the magic finger. You guys ready for the magic finger? All right, magic finger. So everyone, write me out. Write me out. At this current moment, put your magic finger on 0. Magic finger on 0. Now, sine is which value?
Y.
Y value. Can you tell me what the y value is at 0 now?
0.
Put your finger on pi over 2. Okay. What is the y value of pi over 2?
1.
Put your finger on pi.
0.
And the y value there is?
0.
Now, trace your finger. Where's 3 pi over 2? 3 pi over 2. What is the y value?
-1.
-1 down here. And all the way over to 2 pi.
0.
So we get 0. Hey, look. That is the graph of the sine wave. Easy?
Yeah.
Yes?
Yeah.
Yes? Okay, good. All right. All right. Graph is continuous over the entire domain. That means that there's no kinks, jumps, asymptotes, or holes. It is going to be continuous all the way through, from negative infinity to positive infinity. Okay, x-intercepts in the form of n times pi. Period is 2 pi. So you need this. So the period is what?
2 pi.
So for sine, the period is?
2 pi.
So when I say, hey, sine, what's the period?
2 pi.
You would say 2 pi is the?
Period.
Of?
2 pi. Sine.
Thank you. There we go. Okay. Just trying to trick you on that one. All right, so now this next one. Magic finger on 0. Magic finger on 0. So now that you're on 0, now, let's see. Cosine is the x value, right?
Yeah.
What is the cosine at 0?
1.
Now go over to pi over 2. Trace over to pi over 2. What is the x value at pi over 2?
0.
There we go. Okay, next one. At pi, trace over to pi.
-1.
-1. Trace over to 3 pi over 2.
0.
And 2 pi.
1.
Back up to 1, right? Hey, look. We did it. We did it. We did it. Hooray. Is this easy?
Yeah.
Unit circle helps out a lot. Okay. So, graph is continuous over the entire domain, and the period is
2 pi.
2 pi. So, when I say the cosine period is, you would say,
2 pi.
what's the period of cosine?
2 pi.
So, all the time, 2 pi represents
Cosine.
cosine period, right? Period of cosine. Okay, so, I'm going to try and confuse you here. You ready?
Yeah.
Okay, so, right here. So, this is going to be your x values. So, magic finger on 0. What is sine at 0?
0.
Now, this next part down here says 2 times sine. But we just said the sine is 0, right?
Yeah.
So, what's 2 times 0?
0.
Very good. Now, put your magic finger on pi over 2. What's the sign at pi over 2?
1.
1, so I'm going to write 1 right here. Now, what is 2 times sine?
2.
It's 2 times what I had there, right?
Yeah.
Magic finger over to pi. Now, what is sine at pi?
0.
What is 2 times sine?
0.
0.
Magic finger to 3 pi over 2.
Negative 1.
Negative 1.
Negative 2.
So 2 times sine? Negative 2, right? Okay, so now
0.
put your finger on 2 pi.
0. 0.
2 times sine? Is that easy?
Yeah.
It's like really easy, isn't it? Alright, so what can I tell me that this thing out front here does?
Times it by 2.
Times it by 2. But what do you think that does to my values?
Increase it by 2.
By a factor of 2, right? So that thing that's out in front is going to multiply times that, so it's going to change the amplitude. It's going to increase it. So the amplitude is what it's going to be. So you guys actually deal with amplitude every day when you go plug in your phone. If you look at your phone charger, it probably says 2 amps or 2,000 milliamps. Yes.
Mine says 5 amps.
Yeah. Yours 5 amps?
My other phone 1.
Wow. Serious? Wow. Okay. Anyway, that's like one of those super fast chargers.
Yeah.
Yeah, it is. Okay, so now amplitude means how big the wave is going to be, up and down. Okay, up and down. So that's what it means here, that the amplitude is going to go up and down so much. Because electronics get fried if you put too much in there. Okay? So if the wave is too big, it's going to fry your stuff. Anyway, but you guys do deal with amplitude all the time.
They tend to plug a computer laptop charger into a Nokia. It's too big.
Oh yeah. Okay, probably. All right. Anyway, amplitude is the period of a periodic function is half the distance. Here, let me just go back to here. All right. Here's the top, right? Where's that at?
Pi over 2.
No. How?
2.
It's 2. Where's the bottom at?
Negative 2.
How far are they apart?
4.
How far are they apart? How far is there to there?
2.
Say it.
4.
Loud and clear. You say.
4.
4.
From here to here, it's
4.
from there to right there is going to be.
4.
So half that would be
2.
2. And that's where we get our amplitude from. Amplitude is going to be the positive number. Where if there's a negative in front of it, it means direction. I don't mind if you guys put a negative for amplitude, because if it's a negative 2, it just means that the amplitude is still 2, but the negative tells me the direction it's going to go. So since this is positive, it goes up. So if it was a negative, it would go
Down.
down. It would start going down. That's all it does. It just changes the direction that it goes. All right, so blah, 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 amplitude, bam. All right, so now this is going to be sine of 2x. Sine of 2x. So now the 2 is inside there. Inside for my angle. So here's my x's that I'm plugging in. So now what is
0 times
2 times 0 is?
0.
0.
Now, what is sine of 2x?
0.
0. Okay. Now, let's do the next one. What is 2 times pi over 4?
2
Pi
pi over 4.
over?
Can you visit her?
Yes. What's up, my dude?
Hello, how are you?
He wants to wrap his face in a hoodie.
She's getting upset because something did something funny.
You did?
Yeah, she gets upset for no reason. See? Now you believe
No.
me. Now you see what I'm talking
I
about.
know. I'm not saying that. Listen, bro. Do me a favor. Come on up here. Come on up here. Right behind here. I'm not saying there's no reason. I'm just saying, should you be doing that?
No, but it's for the littlest thing she gets mad about. She has bigger worries than me.
All right. So, you got something to work on?
Yeah.
Okay, good. All right, so now, where are we at over here? So we said 2 times pi over 4 was pi over 2, right? So pi over 2, because it's going to look like this. 2 times pi over 4. And then I could reduce it, right? Because that's 2 pi over 4. Yeah? And that reduces by a factor of 2 to be pi over 2. Are we okay here?
Yeah.
Okay, I'm just reducing by a factor of 2 right here. Because I'm multiplying and dividing by the same. So I could reduce that. So that's going to make the math a whole lot easier. Now, magic finger. Put the magic finger at pi over 2. What is the sine of 2x then?
2.
Remember, this is the 2x, right? This is my 2x. This value right here. That's where I get the pi over 2. So if I say sine of 2x,
Oh, it'll be 1, won't it?
sine of this one right here, right?
Yeah.
So sine of this is going to be 1. Does that make sense? I'm calling it 2x because right here in the line above, I figured out what 2x was first. So we know what x is, so we figure out what 2x is, and then sine of the 2x, because this is the 2x.
Have to be 1 over 2. So the next one?
Almost. Okay, you ready?
2.
So what is 2 times pi over 2?
1.
1 pi, right? 1 pi. Now what is sine of 2x?
2 pi.
Okay, let's try again. Put your finger on pi. Put the finger on pi. Not up here at the board. Okay, your finger's on pi, right? Your finger's on pi. So if our finger's on pi, what is sine of that?
0.
Sine is the y value, right? Sine's the y value. What's the y value at pi? At pi. At pi. There we go. Okay. So it's kind of confusing because we're starting with this, right? We're starting with this. So it's starting with, so it's going to be 2 times pi over 2. And this is my sine of that. So does this make it a little bit easier to see? So if you guys look at it, it's pi over 2 is what I have here, right? And it's 2 times that, so that turns into just pi. So now I'm done with the inside. Now I say, what is the sine of that? And that's where we get the 0. Play? Does that make sense? Yeah. Okay. All right, let's see. So 3 pi over 4. So that times 2. 3 pi over 4 times 2.
3 pi over 2 is 6 over 8.
3 pi over 2, right? 6 over 8. 3 pi over... No, it's just 6 over 4, right? So it's 3 pi over 2. Yeah? Now, magic finger. Put the magic finger on 3 pi over 2.
That's over 2.
Okay, so what is the sign there? What is it?
-1.
Negative 1.
Oh, 2 pi over 2.
You want to do the magic finger with us?
Sure.
Okay. Since I'm pretty sure you want to give someone the magic finger.
Also, you took my.
Yeah, you can do it with your finger.
Was it all folded up? Did it look like this? Or did it look like one of these other messes?
Oh, it's one of the other messes.
Okay, can I just give you a new one?
Mine has scribble on the bottom. Don't take mine.
You have scribble on the bottom.
You
Up
are
your shoe.
scribble.
Alright, so now let's do this next one. You ready? So, 2 times pi.
2 pi.
2 pi. Very good. 2 pi. So now, magic finger.
0.
Magic finger. Put the magic finger on 2 pi.
Which one?
This guy. Magic finger. Put it on 2 pi. It goes x and y. So we're looking for the y value. So the y value is what?
0.
0. Okay. Let's do the next one. 2 times 5 pi over 4.
5 over 2.
5 pi over 2, right? Alright, so now, you guys,
There's no 5 pi over 2.
we're going to do a pattern, and you're going to tell me how to answer this, alright? So, I need you to put your finger on 0. Okay? Put your finger on 0. So everyone has their finger on 0. Finger on 0. And you're going to trace this, and you're going to have to follow where it goes, alright? So, start at 0, and go to pi over 2. Okay? Did you guys do it? Okay, you just traced it, right? Okay, so now, keep your finger there. Now go from pi over 2 to pi. Trace it from pi over 2 to pi. From pi over 2 to pi. Here's pi over 2. Okay, and we're tracing it to pi.
Show me 1.
Okay, now follow the pattern. Now you're going to trace it over to 3 pi over 2.
Then 3 pi. Then 5 pi over 2.
Okay, did you trace it to 3 pi over 2? Okay, and now trace it over to 2 pi. Okay, so now where do you think 5 pi over 2 is going to be?
Pi over 2.
Excellent, it is going to be at pi over 2, isn't it?
So it's 2.
So if you started at 0, let's do it again. Start at 0. Okay, start at 0. Go 0 to pi over 2. Now pi over 2 to pi. Then from pi to 3 pi over 2. 3 pi over 2 to 2 pi. And 5 pi over 2 will be where?
Pi over 2.
Pi over 2.
At pi over 2. You notice? Look at this skip. Here to here. Here to here. Here to here. Here to here. There's quarters right there, right?
Yeah.
Okay. Alright. So, you got your finger at pi over 2, right? So what is the sine value of pi over 2?
2.
Say 1.
1.
Thank you.
Like 2 times 1.
No, remember, we already did this. That's what the 2 times is right there. Okay, so the next one. The next one is going to be 2 times 3 pi over 2, which is going to give me
Wait.
6 over 2.
6 over 2, which is
2.
6 over 2,
3 pi.
3 pi. 3 pi, right?
Yeah.
Because it's 2 times 3 is 6, right? And 6 divided by 2 is 3, right? Okay? So now, you guys ready for the magic finger? Put the magic finger on 0.
Wouldn't it be at 180?
Shh. Put the magic finger on 0. Is the magic finger on 0? Let me see the magic finger on 0. Now, since we're counting by pi's, so now trace over to pi. Now trace over to 2 pi. Now trace over to 3 pi. We're counting by pi's, right? And so where would it end up at?
0. Pi.
At just pi, right? It ends up at pi. Because this is a periodic function, it keeps repeating over and over again. It keeps going around the circle. So, what is the sine at pi?
0.
0.
That's not 0.
Okay? Now, let's do this next one. What is 7 pi over 4 times 2? 14 over 4, which reduces to
17.
7 over 2. So it's 7 pi over 2, right?
Yeah.
So now, let's take a look. If 5 pi over 2, 5 pi over 2, remember, where was 5 pi over 2?
Pi over 2.
Pi over 2.
Right? Okay.
3 pi over 2.
And then it went 3 pi, right?
Yeah.
180.
And then 7 pi over 2 would be down to where?
Pi over 2.
Down to 3 pi over 2. You guys agree? Do you guys see the pattern here? Anyone not see the pattern?
No.
You don't. Okay, you ready?
Yeah.
Magic finger. Okay, start at 0. Okay, so watch the pattern. So now watch what your finger does. Okay, so you're watching your paper, not me. Okay, so now start at 0, trace to pi over 2. Now trace to pi. Now trace to 3 pi over 2. Okay, so if you do it around the outside, it makes it a little easier. Okay, so 3 pi over 2. All right, so now trace over to 2 pi. Now trace over to 5 pi over 2. Now trace over to 3 pi. The next one will be right there. That one's going to be 3 pi, right? Okay, so the next one after that would be 7 pi over 2. There you go. That's it.
Oh, okay.
So there's a pattern for it, right?
Yeah.
So where's the pattern? That's what I'm trying to get you guys to get. So now right there, what is the sine value right there?
-1.
-1.
Very good. And 2 pi times 2?
0. Oh, 2 pi.
4 pi.
4 pi. Now, did you find 4 pi? Did
Zero.
you find 4 pi?
Yeah.
Okay, so now what is the sine value of 4 pi?
0.
0.
0. It's not too bad, right? You want to do it again?
Yes.
Okay, let's do it again. And now this time, so. Okay. Remember, this is the multiplier right here, right?
0.
So 4 times 0.
0.
What's sine of 0?
0.
Because it's the sine of 4x, right?
Yeah.
Because the 4x is this one. Okay? So now let's look at the next one. What is 4 times pi over 8?
4 over 32.
4 times pi over 8. Now in a fraction it looks like this. 4 is a whole number, so you put it over 1, right?
Yeah.
So I multiply the fraction. That's going to be 4 pi over 8, right?
Yeah.
I could reduce those
To 2.
by a 4, right? To be what?
2 pi.
Pi over 2. Pi over 2, right? Okay, so now this number here is going to be pi over 2.
1.
Okay, so find the sine at pi over 2.
1.
1. There we go. Now, let's do it again. So 4 times, what's the next one? 4 times pi over 4.
2 pi over 4.
4 times pi over 4.
4 times 4 over.
Can I reduce here?
Yes.
I'm multiplying by 4 and I'm dividing by 4.
So 2 pi.
Just pi, right?
Yeah.
Because if it's over 1, right, it's going to be 4 pi over 4, which reduces to just
Pi.
pi. Magic finger.
0.
Magic finger goes there on pi, so my answer is 0.
0.
If you guys need to actually write it out, you can. Okay. Alright, so now next one is going to be 4 times 3 pi over 8.
12 over 8.
12 pi over 8.
12 pi over 8. Does that reduce?
Yes.
What is it?
3 over 4. 3 over 2.
Yeah, 3 over 2.
3 over
2.
2. 3 pi over 2, right?
Yeah.
Okay, so
-1.
3 pi over 2. So the sine value at 3 pi over 2 is -1. Does that make sense?
Yes.
Is it? Are you feeling good about this now?
Yep.
Okay, so we're gonna get to graphing this here in a moment. Sorry, my throat is parched. I'm talking too much. All right, so next one is going to be 4 times pi over 2. Four times pi over 2. What does that give me?
4 pi over 2.
4 pi over 2, which reduces to
2 pi.
2 pi.
2 pi. Very good. So this is 2 pi.
0.
So what's sine at 2 pi?
0.
0. Damn. You feeling good on this now?
Yes.
25.
Okay, so now let's take a look. What is 4 times 5 pi over 8?
25 pi over 8.
Okay, can you reduce it first? Let's reduce it by a factor of 4 first. No, don't multiply by the 5. Try to reduce it. You're going to reduce the 4 and the 8. So if you look at it like this,
Oh, so
5 pi over 8, I can reduce it by a factor of 4, right? So that's going to turn into 1, and this becomes 2.
So 5 pi over 2.
5 pi over 2, very good. 5 pi over 2. So you can start doing this as mental math now, right? So 5 pi over 2, you guys remember where 5 pi over 2 is?
1.
1.
There we go. 3 pi over 4 times 4.
12 over 4 to 2 over 4. No. 2 over 2?
Mental math, remember? Are you multiplying by 4?
Yeah, 4 times 12. 4
And, don't do the top, because you're reducing. Okay, don't do that. Reduce before you multiply. You're multiplying by 4 and you're dividing by 4 here, right?
So 3
Yeah.
pi.
So it's what?
3 pi.
3 pi, very good. There's my mental math.
0.
3 pi, and sine of 3 pi is 0. So again, mental math. So it's going to be 4 times 7 pi over 8.
7 pi over 2.
7 pi over 2. Yes?
Yeah.
Wait. 4 times 6.
Don't multiply by the top.
No.
Don't multiply by the top. It's mental math here. Because it's 4 times 7 pi over 8. So, from right here, if you multiply by the top, you get bigger numbers. I don't want bigger numbers. I want smaller. So reduce before you multiply. So we know that 4 over 8 gives me
2 pi.
1 over half. 1 over 2, right?
Yeah.
So cancel, reduce, and this gives me 2, right?
Yeah.
So I get 7 pi over 2.
This is negative.
Okay? So 7 pi over 2. So I get what?
Negative 1.
Very good. And 4 times pi?
4 pi.
4 pi.
4 pi.
So it'll be 0.
That's 0. Okay?
Yep.
Alright, so I'm gonna teach you guys how to graph this now. So this actually says some stuff, but don't worry about it. I'll tell you how to do it. Alright, so first, what is the amplitude?
Amplitude is the number multiplied by
Okay, so what is it?
2.
It's not 2.
2. No. Sine of 2.
Nope. What's the amplitude here? What was the amplitude here? We multiplied everything by what?
2 pi.
2. We multiplied everything by 2.
Yeah.
That is the amplitude, remember?
Yeah.
The amplitude is in front of my number.
I said 2.
Yeah, it's still wrong. Okay, amplitude. What's the amplitude here?
Sine 2x.
Nope. It's 1.
Oh.
So that means it's going up to 1 and down to
1.
negative 1. Down to negative 1. That's what the amplitude does. Remember? Makes it go up and down, right?
Yeah.
Okay, so if it was 2, it would go up to 2 and down to negative 2, right?
Mm-hmm.
Okay, so that was a trick question, trying to see if you guys follow along. All right, so now, the period for sine. The period for sine is always what?
2 pi.
Very good. So I would say because I'm having this, I have to start with my period, right?
Yeah.
Then start.
Where does sine start at?
0.
Thank you. So it would start at 0, all right? But I'm going to take this right here. I'm going to show you how to do it. Because the period is supposed to be 2 pi, right?
Yeah.
And you take this, set it equal to.
2x. What are you trying to solve for?
What are you trying to solve for?
2x? Oh, period.
To solve for the period, you figure out what your x is.
Divide by 2, divide by 2, so it's x equals pi.
Yep, divide by 2, divide by 2, so x is pi. So the period is how much?
Pi.
Pi.
Pi. So it's pi, right? Okay. So I have amplitude, period, so my period is pi, so that means it repeats every pi, right?
Yep.
Every pi, it repeats the whole thing. So now where does sine always start?
0.
0. And where's this one going to end?
2 pi.
Nope, try again.
3, 6.
Nope, try again.
No.
Say pi.
Pi.
Thank you. Because the period is one whole cycle, right?
Yeah.
Because this 2 on the inside changes that. It makes it go faster. Okay? It makes it go faster. And that's what that does. So the number on the inside makes that piece go faster. So it changes the period. My period for sine normally is 2 pi, right? But since this is 2 times that, that means what?
It's faster by 2 times.
Yeah, it goes 2 times faster. So that means instead of finishing in 2 pi, it finishes in
1
pi, in 1 pi, right? Does that make sense? Hopefully? Okay. So I know that I should have a start here and an end here. What is in the middle right between 0 and pi?
Pi over 2.
Pi over 2. It's half the distance, right?
Yep.
Yeah.
Pi over 2.
It's gonna be pi over 4 for the top one.
So right here, this is pi over 4 because that's halfway in between, right?
Yes. Then the next one will be 3 pi over 4.
Yep, 3 pi over 4. Okay. Yes?
Yep.
Okay, good. So we're going to find these values now. Sine is always talking about my y value, right? So let's take a look. So 0 times 2
0.
is 0. What's the sign at 0?
0.
Next one.
Um,
Pi over 4 times 2.
Won't that be 2 pi? No.
Pi over 2, right?
Yeah.
Yeah.
Yeah, it's pi over 2. Okay, sine at pi over 2?
Pi over 2 is 1.
1. Alright, the next one says pi over 2 times 2,
Pi.
pi, right? What is sine at pi?
0.
Am I losing anyone here? Are we okay?
I kind of don't get it.
Okay, so now, you're going to help me with this next one then. Okay, so we picked these numbers because I know what the start is, I know what the finish is, and I needed to have the parts in between. It makes a perfect 4 parts. Okay, in between each of these spaces is going to be one of those parts. Okay, so now, you ready? I'm going to take 2 times my x value, which this is my x's, right? 3 pi over 4. Now, I could reduce this by a factor of 2, right? So that's going to go away, and this is going to turn into,
3 pi over 2.
very good. So I got 3 pi over 2 now, right?
Yeah.
So this is 3 pi over 2. Now that I got the number, put your finger on 3 pi over 2. What's the sign at 3 pi over 2?
-4.
Better sense?
Yes.
Okay, let's do the last one then. So last one. Okay, anyone else struggling here? Okay. So let's take a look at this next one, the last one. So it's going to be pi times 2.
2 pi.
2 pi.
0.
0.
Okay, so 0, right? So there we go. Now we're going to graph this. How high does this go up? 1, because the amplitude is 1, right?
Yeah.
And it goes down to,
-1.
very good. So if I'm starting here at 0 and I'm ending at pi, this one right here, we said, what's my middle?
Pi over 2.
This one,
3,
pi over, and this one
3
is?
pi over 4.
So I have nice, neat increments here. Okay, it's breaking up into 4 parts. And the reason why I do this is because a wave has a pattern. If you know the start, you know the finish, you break it up into 4 parts, and all these ones are going to give you good spots on my graph. So let's take a look. So 0, 0, so I'm going to use a different color here so I can show this one, right? So 0, 0, it's going to be right here. So at 0 at 0. At pi over 4, it's going to be 1. So I go up here. At pi over 2 it is?
0. -1.
At, right here, I get -1, and what I just did there is,
Create a wave.
I graphed my wave.
You messed it up.
No, I didn't. I created a nice, pretty sine wave.
Isn't there a name for that?
A sine wave.
No, there's a name for
Sonic wave.
No.
Tidal wave.
I'm going to change that for you.
No clue. Think about it though, okay?
No, because Miss Crabtree was, because we did the same thing in Miss Crabtree's, and there was names for the lines. Maximum.
Max, min.
Yes.
Okay.
Maximum.
Okay, yeah, you can. So, but this one, you guys have probably talked about like parabolas and functions and stuff like that. So yeah, it'd be like this, but these are periodic, so this is gonna repeat the same pattern in both directions. So now, if I'm looking at this on the left, what is it? If I'm going left on this now, which way would this go? It'd go down first, right?
Yeah.
Then back up, right?
Yeah.
And it would keep going that way, right?
Yeah.
It's periodic, so it means that we're only talking about just one period of this right now.
Okay.
Does that make sense?
Yeah.
Does that make sense, you guys, everyone? It's not bad. Like, graphing this is actually pretty easy. So, we're going to work more on this Monday. I just wanted to get through these two examples, so I'm going to come up with this one tomorrow, and you guys will have it, okay? Or Monday, I'm sorry. All right, don't forget, like and subscribe. Notification, right? Remember?
Oh, I forgot you were recording.